Okay, we keep talking about some amazing training facilities that we get to visit, but did you know that there is a technical training facility on the 42nd floor on Broadway, right in the heart of New York City, actually overlooking Times Square? So, Fujitsu has this most amazing technical training facility called Air Stage on Broadway, and it is designed to be a training spectacle. And I have to tell you, that is exactly what it is.
Doesn't know something, they can't teach it, they don't teach it, students can't learn it, don't learn it, they can't do it. So how do we train our teachers?
The facility is designed to be a learning and sharing center showcasing the latest energy-efficient commercial and residential heating and cooling systems. Learn more about this amazing training facility at theairstage.com.
All right, everybody, thank you for joining us once again on Did You Know, the ESCO HVAC show. All right, Ty, this could be somewhat of a controversial one for people. We hope that it's not, because we're gonna simplify some things that at least I haven't seen talked about much in our industry. And so you and I have been having a lot of fun. We've actually got to the point where we purchased our own oscilloscopes, and we're diving into the communicating signals on ductless systems, right?
Had some positive and negatives.
A little bit. Oh boy, love that one. And absolutely. So we're going to explain to you what's going on in two different communicating platforms that are happening on our ductless systems. So we're going to talk about the communication that's happening from the outdoor unit to the indoor unit, and then we're going to talk about the communication that's happening from the indoor unit to the remote control, because they are actually very different, but they have some similarities. And so we're going to do some hands-on along the way. So make sure to hang in. We're going to show you how to check these voltages as we go along. Got a variety of different camera shots. I've actually got here on this side, I've got a whole indoor unit connected to the outdoor unit behind me. So it is going to be a live functioning unit. And we'll check voltages with AC, DC, and we'll take a peek at those with the oscilloscope to see how they intermingle with each other, because they actually do intermingle a little bit. So let's hop into understanding what's going on, and make sure to let us know where you're joining in from. Hey, what's up, everything HVACR? That's right. Ty is a great guy. We have so much fun. I'm so glad Ty joined the group here. It's really it's so nice, because now we have different perspectives and we are pushing each other in ways that, we don't always think about being pushed in new directions. And so I think Ty and I have been very good at pushing the boundaries for each other. It makes us explore things, because right here, we were talking about measuring this, and Ty's like, I think I want to get an oscilloscope. I'm like, oh my gosh, Ty, we got to get oscilloscopes and we got to measure these suckers and see what's actually happening with them. And so that's kind of where this came from. So I'm going to call this ductless electrical. This is not a class that we've done before, so there's going to be a lot to talk about here. And I've been working on this one for quite a while, trying to get some of the explanatory things down. And then the hands-on will actually kind of bring it around to be able to see exactly what we're talking about. So for those of you, who know me well, know that I don't really enjoy books. I have a hard time connecting with books, especially lengthy books. You know what I mean, right? Hey, Greg, what's going on? So glad to have you here with us. So I will read a book if I know that it has, something that I'm yearning to learn about. Now, what is good for me? Hey, Josh, what's going on? Yeah, you're right, man. This is how I learn. So I have learned by reading manuals, because that is the one thing that I absolutely love. I'm a dork when it comes to installation and service manuals, because they tell me everything about something. And so I like to look at wiring diagrams and spend time in manuals. We're going to use reference from a few different manufacturers so that we can bring this thing all together, so you can see that every manufacturer actually uses the same kind of communicating platform. Remember when we were doing unitary communicating systems, so split systems, we were showing you how we used, a 5 volt or 12 volt DC system to communicate. I want you to see what we're actually doing here on ductless, because this is crazy. When you see it, you're going to go, oh, wow, there goes that crazy camera again, Ty. I don't know what this thing's doing. All right.
Well, I
So let
gotta
me,
tell you, I spent some time in Australia,
yep.
so I'm all about AC/DC.
ACDC. Ooh, ah. Well, it's what we're going to talk about. All right. That was a good one. Okay. So let's start out on our diagram here. We're going to talk about AC/DC as it pertains to HVAC. Man, that could be a song right there. All right. So look at the schematic. Now, see what I did? I'm going to try to keep these wires similar so you can see what's going on. So when we talk about bringing power to the outdoor unit, we're going to bring in single phase. So we're going to talk about single phase today. Three phase is pretty much the same, but we're going to talk about single phase. And I'm actually going to be using this 120 volt ductless system over here so you can see what we're looking at voltage wise and how that pertains to a system. But 240 is the same way. We use the neutral or the, we're going to call it a shared line. It's where the AC and DC plays footsey. We're going to show you on that. Yeah, I'm telling you, Ty has absolutely got the jokes. All right, so take a look at this. So we've connected the outdoor unit to the indoor unit. And so we have 1, 2, 3, and ground. Okay, that's our 4 wires being connected from the outdoor unit. A lot of people ask, what is happening on those wires? Okay, we're going to break it down very, very clearly, I hope, today. So, Ty, let's look at those wires. So we brought that 4 conductor wire in, right? So we've landed that from the indoor unit to the outdoor unit. We've powered up the outdoor unit. Now, when we look at those wires, let's follow that number 1 wire and see what we actually have. On that number 1 wire, there you go. There we've got our 4 conductor. Exactly. On that number 1 wire, we're going to feed hot. So this particular one's 120. If it was 240, it's still going to be one of the hot lines running from the outdoor unit. We're going to bring that through our control board, and we're actually going to utilize that to be able to feed our inverter circuit, right? Our rectification circuit with inside of our inverter board. So when we come through that board, we're using that number 1. We're going to go into a rectification circuit. I called that an inverter board. I shouldn't have done that unless it's actually got a 3-phase indoor motor, which is possible. So we'll just call it our control board on the indoor unit. So I'm bringing that single phase AC in on number 1. I'm going to bring that over. I'm going to feed it into our AC to DC rectification circuit with inside that indoor control board. Now, let's continue to follow this thing along all the way because it'll help you understand what's happening on that signal wire that a lot of people call it, or number 3 wire, because it's actually part of an entire circuit. So on the other side of that AC in for that indoor control board, we have a complete circuit on number 2, right? So if it's 240, that's going to be another hot line. If it's 120, it's going to be a neutral line. It's going to be white on this particular one a lot of times. Okay, so now we've supplied AC power to that indoor control board. Now it completes itself back to a transmission circuit. Okay, so we actually are using communication all the way back to that number 3 wire. So we started out high voltage on number 1 and number 2 AC, came in through our circuit, and now we have a transmission happening on number 3. So the interesting thing about this transmission is we're actually going to be utilizing a DC signal, and it's going to be shared on number 2 on this particular scenario. And I'm going to show you what it looks like on a 120 and a 240. So we're going to share a communication circuit, but we're going to have AC and DC all traveling on these 3 wires. And we'll prove that here in just a minute. So on that indoor control board, if I've got DC that is going to be running the indoor fan motor and running my thermistors, I'm actually just going to come off from that voltage rectifier. I'm going to have a DC voltage supplying whatever function I have. So this particular one is using a DC motor driven off from that same circuit. And we're going to use a 5-volt DC to run most of our transducers, pressure thermistors, a variety of things. Okay, so let's take a look at what we've got here on the actual connection. So we're bringing our power to the outdoor unit. We're feeding to the indoor unit. I'm going to use a variety of pages from different installation manuals. So all of this is from different manufacturers, but showing what we're doing there. So as we land those, it's extremely important that we land the wires correctly from the indoor unit to the outdoor unit, and we have a dedicated ground wire. That dedicated ground wire is extremely important. We want to make sure that we're not connecting it into a ground circuit of like a 120-volt lighting system, because now we're actually going to be using this to form some of our communication, and it's important to have a dedicated ground reference. Okay, so let's look at this other manufacturer here, and we're going to look at this outdoor unit this time. Okay, so from this outdoor unit, we've got our main power coming in. So we're feeding over to DB, which is our diode bridge. So we're coming in with our AC power. This is actually where most of our DC, starts from. So we're going to feed AC power in from L1, L2 over to our diode bridge. We're going to create a DC voltage that's going to be used in our processing, but there is that number 3 wire. And if you notice, it lands on its own terminal called S, or signal. Now, this particular wiring diagram doesn't tell us what we're doing with it. That's because it's being used in this transmission circuit. But it's absolutely going to be a DC signal shared with a common AC line. We're like, well, man, how do we do that? It's quite interesting. And we'll talk about that here in just a minute. Okay, so we're going to feed our AC in. We're going to get our DC circuit. And now when we're talking about our inverter, we can actually run right on through. What you got, Ty?
I was just trying to show the S, but it's not going to show up on the camera.
Okay, so that particular one has an S on that third wire, which a lot of times is designated with a red wire. All right, so that's how we feed DC to our inverter. And so that DC is going to be spent back around and utilized on that S terminal. I won't dive too deep into this one because this is how an inverter functions, but it's just showing that we are using AC and DC on all those. That DC voltage we're going to utilize as a constant 5-volt DC to run our pressure transducers, temperature thermistors, a variety of different things. All right, so let's take this 230-volt application, and I'll show you on this 120 what it looks like as well. So on that 230-volt application, number 1 is hot, number 2 is hot, number 3 is our common, right? But it's actually that signal that's coming through. So when we're tying these together, it's very important that we're keeping those lines 1, 2, and 3 tied to 1, 2, and 3 of each of the indoor units. When I was doing technical service advising, I had many calls where, hey, this thing's acting really funny. I'm not getting anything out of this one indoor head, and the other one's running, and I've got a low pressure call, and most of the time is because we had those wires crossed between which indoor unit. That's the reason we label those like this particular. This is the one that I use here for the shop and for the garage and the wood shop. So this is a 3-ton 4-port. So it has A, B, C, and D. Critical that the A from the outdoor unit is connected to the A indoor unit all the way through those. So I'm actually just using 3 heads on this particular installation. But the wiring is 100% crucial on that. Okay, Ty, let's talk about what we're actually doing on that S wire. Has anyone ever talked to you about pulse distance encoding before?
Pulse, absolutely. Every time I go to the doctor, they're always checking that.
Okay, think about that, right? What are they reading when they're taking that measurement?
They're reading their heartbeat.
And they're reading that
pressure.
as a 1 for a pulse with pressure.
Yep.
And they're reading no pressure. And we can actually
Right.
measure the velocity. We can measure the volume behind it. Remember, pressure, voltage, we're going to be utilizing those terms comparatively quite often. Okay. When we start talking about using AC, AC flows on a nice clean sine wave, but we can't do much with it, right? With DC, we have a constant reference and we can apply voltage and we can remove voltage. That's how we do like SOS. That's how we do a lot of communications. And so when we look at pulse distance encoding, we're able to take DC voltage and we're able to do 2 different things with it. We can turn it on and turn it off, but we can also measure the distance when it is on and when it is off, and we can vary that with DC voltage. So we can actually take DC voltage, once we've ran it through that rectification circuit from AC to DC, and we can now pulse it. Exactly, right? we can use those pulses to write code. When we talked about SOS, that's all we were doing is we were supplying, we're talking 100 years ago with SOS, 130 years. We were able to take voltage, DC voltage, apply it, and we would get a response connected to a light, connected to a speaker, connected to a device, so connected to a needle, so we can actually, make long printouts of it on a scrolling piece of paper. So we would have voltage applied, recognized as a 1, no voltage as a 0. Measure the distance of those. Now we can start speaking in a language, right? We can give different commands. It's communication. It's exactly like what we were talking about with that 5-volt DC communicating on most of our communicating unitary systems, right? All what we're doing is speaking different languages between different manufacturers. They're actually using the same technology. They're using pulse width encoding or pulse width modulation. You'll actually see it like that. Yeah, Murph, that's right. We're going to actually get to that flashing light. You think that's a joke? Wait till you see what we do with these flashing lights here in a little bit. We're going to show you something really cool when we get to the indoor unit and we start talking about infrared. We're actually going to be able to record the infrared pulses that are being used on a remote control. That's going to be kind of cool. All right. So now that we've cleared that, let's think about it. Yeah, no police behind you. It's just Ty. Wait
It's not
a
the
minute.
80s. We don't have police anymore.
I just want to know why he's watching us going down the road. That's what I'm interested in. Busted. Okay. All right. So that address and that command can change between manufacturers. And that's really the only thing that is different when we start connecting different manufacturers' indoor units and outdoor units. Because if we think about it, I mean, Ty, let's think about the primary components in an outdoor unit on a ductless system. Let's run through them.
Oh, we got a compressor.
Yep.
We got a condenser fan motor.
Yep.
Condensing coil, which is not electrical.
Yep.
Electrical side, we have a control board to control that compressor.
Yep.
Reversing valve.
Yep.
Some sensors.
Yep. Metering device.
Yes. Metering device. Yep.
Yep. And so then let's think about the indoor unit. What's on the indoor unit?
Oh, evaporator coil, control board, blower. That's it.
Maybe some temperature
Very
thermistors.
simple.
And that's it. So why can't I connect manufacturer A indoor unit to manufacturer B outdoor unit? It's this. So it's the pulses that we actually use. And so we haven't come to a unified platform. When we were talking about the automotive industry actually took that 5-volt DC. If you were working on a vehicle when we went from carburation to fuel injection using integrated control boards, every manufacturer had a different code. And then they finally unified and came up with a common code, and we called it OBD, onboard diagnostic. And that's really just the code that they were using so that every manufacturer would use the same. It changed. We had OBD 1, 2, 3. We haven't done that in the HVAC industry. So unfortunately, they don't talk to each other very well. Now, there are engineers out there, I say engineers, there's a bunch of engineer nerds out there that are breaking code regularly, trying to figure out what everyone is saying, trying to make them work together. But then you get lawyers
translator.
That's exactly what it is. It's just translation. So if we were wanting to make Company A work with Company B, it's just simply a matter of making the signals match each other. Okay. All right. But we're going to do this in 2 different ways on a ductless system. We're going to have one form of pulse distance going electrically DC from the outdoor unit to the indoor unit, but we have a different one from the indoor unit to the remote control. So we're almost there, and we're going to talk about that. It is very different, but very similar. Yeah, exactly. So this is actually what it looks like if we were to take an oscilloscope, which we're actually getting ready to do, and we were to look at what's happening on a DC signal, we'll actually see it. Now, here's where it gets interesting. Can I mix an AC signal with a DC signal? And people go, no, you'll blow the thing up. Well, that's actually not true. So we can introduce a DC signal on the same line. And what happens is, say I've got this AC sine wave going like this, right? And its distances up and distances down are the voltage of it. That's right. Okay. Well, I can introduce a DC sine wave in there, and all it does is takes that AC sine wave and pushes it up when the DC signal goes up, and it draws it back down when it is in negative. So the DC signal can actually occupy the same space. And it's kind of weird to think about that, but we're actually going to show you what it looks like with that oscilloscope. Okay, so this is a pre-recording. I wasn't sure how well things are going to work today when we do the live, so I made sure to pre-record a short one, and I want you to see this, okay? So we're actually measuring in voltages DC, and so you're going to see this particular one jump on voltage DC. You can see the reference, so we're going to have some negative and we're going to have some positive voltages DC using oscilloscope, and all I was doing was reading from number 2 to number 3 of that outdoor unit. All right, let's see if this will play for us. Okay, so what you're actually seeing is that signal, that pulse width communication. So you see how we have some long distances when we're in the positive, when we're on the upper plane, and we have long distances when we're off, right? So Murph, it's exactly right. So it's a crest of a wave and then the trough between the waves. So what we're doing is we're building upon that frequency spectrum, and we can apply both of them into that same signal. So when we're talking about this DC signal, that's exactly what it is. So we are communicating from the outdoor unit to the indoor unit using a DC signal. Now, let's move, Ty. Okay, so we're using DC voltage. And there are sometimes manufacturers will use a different DC voltage from the outdoor unit to the indoor unit. So in the service instructions, it'll tell us what voltage to look for. And it's very easy to do. We'll show you how to read that voltage. So that can be a varying voltage depending on the manufacturer, and the code that they're using will be different. But what about from the indoor unit to the remote control? How do we do that, right? You got your remote. This is the one that I actually used for this test today. So what we're actually going to do is we're going to use the exact same principle. But instead of having a variable voltage, and actually a lot of times on that outdoor unit to the indoor unit, it's a consistent voltage. It might look like it's jumping up and down, but it's just because of the RMS, the speed that our meter is reading that. Now, look at the front of that, Ty. Have you got one of those in the front of yours?
I do.
What is that?
It looks like a light, but I don't see anything coming out of it.
Yeah, hit the button, see if it does anything. I can't see anything
It makes a
happening on
beep
that.
noise over there.
It does make a beep. How did it do that?
Well, I'm thinking it's invisible magic.
Ooh.
Or it could just be infrared.
Yeah, well, invisible magic to our eyeballs. So here's what we do. We actually use light at a frequency that our eyes don't pick up very well. And we're going to do the exact same modulation from that eye that's on your indoor unit. I've got the cover, but it's over there. I might bring it over here in just a minute. So as you can see in that picture right there, that little round eye that you're seeing, that actually is two things in one. So it is a receiver and it's a transmitter, so we can talk back and forth. Not a lot. Most of it's being done from the remote to the indoor unit. And so what we're going to do is we're going to talk in pulse width modulation of light to that indoor unit. And so as we speak, we're actually going to have the same modulation we were talking about from the outdoor unit to the indoor unit. And we're going to do it with an on and how long it is on, and an off and how long that thing is off. And so I want to play a real quick video before we move into the next slide, before we start doing some hands-on demonstration to show you what this thing looks like. So this was kind of fun. I took a little bit of time earlier trying to think of how can we show you infrared? How can we actually record what's happening on that remote? And so I got a little creative, and check this out. Okay, for this experiment, we're actually going to see if we can record the infrared light that is coming from an IR remote. So we had to get a little creative with this. So we're actually going to use a Gen 1 IR rifle scope. Yes, I have one for experimental purposes. So we're going to try to use this iPhone through the lens of our IR scope in pitch black, and then we're going to see if we can record the infrared signals coming out of the IR remote to prove that it is a function of light coming from a IR. Okay, so let's take a look at these pulses at a standard frame rate. Now let's multiply that by 10. You can see we do have some variations. Now let's multiply by 100. Oh, looky there. Now we can see the individual pulses, ones that are on for a period of time, off for a period of time. And let's try a different signal. This time we're going to actually use a fan control instead of the power. And you can see it's a different combination of light pulses. It's pretty cool to think that we're actually using a form of pulse width modulation in our wireless remote control. But instead of using the DC signal like we're using on our ductless outdoor unit communicating to the indoor unit, we're going to do that with pulses of light at a very fast speed and at a frequency that the human eye doesn't actually capture. So by using an IR camera, we can actually record what those signals are and see what those pulses look like. And now we have new products coming to the market like this CIELO Breeze Max, which I really enjoy, that is a more traditional looking thermostat, and you actually pair the IR remote with that thermostat, and then it's able to send those IR signals from the thermostat back to that indoor unit. It needs to be within line of sight by a certain amount of degrees just so that it can read those light signals. But it truly is a thermostat that can be mounted on the wall or mounted on the tabletop as long as it has power supply, and now can act like a wireless thermostat. It's actually just a repeater wireless thermostat. Okay, pretty cool, right?
That is very cool.
I thought that was kind of fun because it's a very visual representation of what is actually happening in that infrared remote. Now, let's look at one other thing here just to show you that different manufacturers do the exact same thing. This is one manufacturer simply showing that we're connecting the wires that exact same way. This was a good one. This is right out of an installation manual from a carrier that shows us the two different wiring combinations for 240 volt versus 120 volt and what is being used as the common. So what you'll notice is that on that 115, 120 volt one on the upper, which is what I'm going to be using on this particular unit right here. This is a 120 volt system. We have that signal happening on S. We have L being our hot, N is our neutral. And if it was a 240 volt, we would have L1 and L2, but we're still going to be able to utilize L2 as our neutral, right? To be able to read that DC voltage. And that's what I want to do for us today. Anyone have any questions yet about where we're at? Haven't seen anything pop up in the chat, and I'm surprised there's not, because I imagine there's people out there going, wait a minute, I don't recognize it like that.
How did you get to be so smart, Clifton? That is absolutely brilliant using that that scope to be able to see that infrared. I am so impressed. That is awesome.
Well, I knew that it used infrared and that it was using an IR light on the detector. And I thought, I wonder if I can read that. And so it just worked out that it did. So
Well,
I'm glad I didn't
not
waste my
everybody will
time.
not everybody will see it, but I think it's a bright idea.
Oh, it's a bright idea. Woo! All right, so let's actually do this. Let's show everyone what we're talking about. I can come back to some slides here in a little bit, and we can dive a little bit deeper. Anyone has questions along the way, definitely hop in there, let us know. All right, so what I want to do, Ty, is I'm going to fire this thing up, and I'm going to bring on this secondary view so that we can take a look at this indoor unit. So this is on the countertop here, right underneath where I'm working. So I'm going to go ahead, and we're going to get this thing fired up. I'll actually get safe here to make sure that we're handling our electrical properly. And we want to be able to prove exactly what we're talking about and see that both on a voltmeter as well as on an oscilloscope. So on this particular one, this meter was on loan from UEI. This is a DM525. I like this one because it's a pretty fast operating meter. I've got a variety of meters around here that all work good, but this 525 will allow us to see this very easily. So what we're going to look for our AC voltage and our DC voltages. So Ty, let's set our meter on AC. We're going to fire this up. I've only got about 5 minutes at a time of test with this unit, because what it does is, even though I don't have a line set connected, we're just connected electrically and my shutoff valves are closed. So after about 5 minutes, the system tries to go through a commissioning, and it actually starts a compressor up and it starts running. And so I want to make sure if I get to there, I'm going to shut it off, and then we'll come back and recheck again. So we're going to use this in approximately 5 minute intervals or so. Okay. So we got our meter on volts AC, and now we're going to go check our signals coming from the outdoor unit to the indoor unit. All right, so on volts AC, let's go ahead and go over and let's double check that we do have 240 volts. So if I go from number 1 to number 2, that is my hot to neutral, right? And it's a steady AC voltage. So what happens if I go from number 1 to number 3 and I look through the DC voltage? Well, isn't that interesting? So my AC voltage isn't consistent anymore. I have something else traveling on this line. And I go from number 2 to number 3, and I'm going to see, wait, I've got some strange voltages popping around from number 2 to number 3. That's because it's not an AC voltage at all. It's actually a DC voltage. So if I set this meter to DC voltage, and I go from number 2 to number 3, well, looky there. I'm actually getting a pulsing DC voltage. I don't read it as consistent unless I do a minimum maximum hold and I see what the peak voltage is. Yeah, we're pulsing right now. So if you read the service manual, most manufacturers will tell you that you're going to jump between 5 volts and 30 volts DC, somewhere in that ballpark. And some will tell you that you have a negative voltage reading from 2 to 3. You might have a positive reading from 1 to 3, but we're going to absolutely see a DC voltage. And that's the communication that is currently happening on this unit. Now, what if I go to just plain old ground, right? Well, isn't that interesting? I don't have any of DC voltage until I get over to number 3. And so I could read from ground to number 3 and actually pick that same voltage up as well. If I was on my AC voltage and I went from ground over to number 3, it's going to be jumping around, but it's going to be somewhat consistent. That's because it's reading the excess AC voltage that we were utilizing, right? So the way that I'm going to double check my ranges on that number 3 is going to be DC voltage, and I'm going to use that between, on this particular one, I'll be able to read this between 2 and 3 fluctuating. And so on the 240 volt system, it's going to be a similar thing. All right, I'm going to shut this down for a second, Ty, just to make sure we don't get into that 5-minute period, because what we're going to do now is we're actually going to start firing up an oscilloscope, and we're going to measure this and take a look at it from a couple different perspectives. All right, so let's reset this. Now let's start looking at voltages and see what we have here between number 2 and number 3. Wait a minute. I've got DC pulses happening on an AC sine wave. Let me see if I can change. I know I can change the range of this. I don't know if I can hold and change range or not. Let's see if I can get that. So what we got now is a total AC sine wave that's going to be reading AC and DC. Let me see if I can get that going for us here. These gloves aren't helping either. So when we're using an oscilloscope to read what's happening, what we'll do is we'll actually, let me shut this down. We'll actually read AC and DC on both lines, and we'll see them jumping together. So what you were seeing was that simulated AC sine wave with our DC voltage jumping back and forth. We'll see if I can't get this reset. Ty, tell me what you were reading when you were utilizing your meter for doing the same process.
Oh, I have a whole page of notes that I was making, but
Okay.
now I got to redo it because you've given me so many really great ideas. And now I'm wondering if we set up a camera that picked up infrared and then we set up a transmitter on your side, if I could control your system with my remote.
I don't see why we couldn't.
There's a YouTube video to where a guy uses music, but he has the music transmitted into an infrared light, and then he has a receiver on the other side of the room that collects that infrared light that then powers a speaker. He was able to transmit music because it's just simply the pulses
signal.
put of speakers. Yep, and it was pretty neat. And then this is that same exact thing.
So our number 2 is utilizing our sine wave from our AC. That range is way off, but what you're seeing is it's a consistent peak. Boy, I got to try to get this range readjusted. But you can see bouncing through the middle, you can see the AC sine wave, and you can see the DC pulses that are happening throughout that AC sine wave. It's really interesting to see is that all we're doing is we're piggybacking our DC. We're playing footsey with our DC and AC on our common line. This particular one, it's using number 2. So from number 1 to 2, I've got AC voltage. Number 2 to 3, I actually have DC voltage. And when I read those with an oscilloscope, I can see both of them happening between 2 and 3. I can see my AC sine wave and I can see my DC sine wave. It's kind of crazy, right? To think that it's that simple. It's just a matter of communicating from the indoor to the outdoor, and then from the indoor to the infrared remote, both using pulse width modulation and both doing the exact same kind of thing. They're just doing it with maybe a slightly different language. Kind of cool.
And it makes the install easier because there's a whole lot less wires.
It does. We can actually talk. That's the reason, like on a unitary system that uses 2 wires, we can do all that communication. On that unitary system, we're simply using a 5-volt DC signal to go, there's a 1, there's a 0, and I measure the time in between it. Yeah, Wesley, absolutely, this is going to be recorded. So every week we do these shows live, and then we'll go back, we'll trim them up, clean out any of the things that we see as obvious mistakes, and then we'll get it set into a finished video, and then it'll be available on our e-learning network. You can actually, if you're looking for CEUs, you can take a assessment along with watching the video to gain CEUs for that for $2.99. Otherwise, the video is for free on our e-learning site. It's also available on YouTube, and this live one will still be on LinkedIn, YouTube, and Facebook as well. So a lot of opportunities to come back and take a look at that. All right, so let's look at a few different manufacturers just so we can kind of recap on this. I think I went through it a little faster than I should, so we're going to have some more fun here in a minute. We'll get this thing fired up and see if we can get the oscilloscope in a cleaner range for us to look at. So let's take a look at this particular one, Ty. This is a different manufacturer, so I tried to grab a variety of manufacturers so we can see exactly what's happening between different brands. So this particular one, this is a 240-volt application. We have our power supply coming in up here on the top right with L1, L2, and a dedicated ground, right, to our chassis. We have to have a good, clean ground. And it is showing us in this wiring diagram that we have L1 making a connection to number 1. We have L2 making a connection to number 2, but our number 3 is going directly to our control board on CN16. So that we have our AC power on number 1 and number 2 to the indoor unit, but we have a DC signal coming out of that number 3, riding back with a DC pulse between number 2 and number 3 back to that indoor unit. All right, so let's change manufacturers. So let's take a look at a different one. Okay, this particular one actually has some pretty decent instructions on doing diagnostics for this. So it's telling you, check if the indicated value swings between 90 volts and 270 volts at the outdoor unit between pins number 1 and number 3. So Ty, how can we be above 240 volts AC?
Back EMF or capacitors.
What about that DC signal? Do you remember earlier where I mentioned that when we apply that DC signal, it actually pushes the AC a little further? We actually
like
have
oil.
We have the ability
oil with a cup of water.
Exactly.
Push the water up.
It's not that they're intertwining, it's that they're actually separating. So our DC pulse actually can move that AC sine wave the way for our meter to read that. Because remember, we're trying to read root mean square, RMS voltage. We're trying to read this average voltage. Well, when our DC signal pushes that AC sine wave, it actually changes some of that voltage. And that's the reason it can drop it down all the way as low as 90 volts, because the DC voltage is pushing that sine wave up and down in reference to ground or neutral. So we can actually have a varying voltage. So they want you to read on this particular brand. That's why it's important to read your service manual. A few manufacturers want you to read it differently because of the way that they're encoding that DC voltage. So if we measure on this particular one, we're going to check between pin 1 and 3. And if it's abnormal, now we got some things we can look for. On check number 4. We're going to check between number 2 and number 3. And now we're going to see what's interesting is this one shows you that you have a AC between 30 and 130 volts, reading AC voltage on that particular one. They don't show you to read DC, but it's there. So if you remember earlier, our AC voltage was jumping around. That was because of that variation of that DC voltage. So just because the manufacturer doesn't tell you about the DC voltage doesn't mean it's not there. It's absolutely there. This manufacturer is just showing you how to test that voltage in AC because not all meters read DC voltage. Okay? So it's important to look at your service instructions to see what they tell you for reading it, but we wanted you to understand what's actually happening. So here is a really cool example of how we can take that communicating signal and decode it. So, Ty, well, I'm already showing you, so I can't ask you. I will say, have you ever encountered a ductless outdoor unit connected to a split system indoor unit, furnace or air handler?
Yes.
Oh, okay. Most people will go, well, how you can't hook a ductless unit to a traditional indoor unit? And I go, well, if you can learn how to talk, why can't you? Howard Weiss always says that ESCO is really like this professional dating service. And so we help people understand that it's like we're all standing around the gymnasium at the dance, right? And we all want to dance, but we don't know how to ask that first time, right? So we always try to help you understand what is out there. And so you can take that next step to dive even deeper with it. And so here's what we're going to show you with this particular unit. If we simply understand the pulses, the encoding, and we understand what that command is, we can do whatever we need to with that. So this particular manufacturer, they will allow you to take this communicating outdoor unit that is using the pulse distance encoding on that number 3. So it's still the same 4-wire. Number 1, let me see if I can get my pointer over here. Number 1, number 2, S for signal, and ground. Ground goes directly up to the bus bar, bypasses the communication circuit. L1, L2 lands into a communication terminal, and signal goes into the processor. And this 24-volt interface module simply uses the commands of a 24-volt legacy system. So if we had a call for cooling, and we can control our fan speeds, our inverter outdoor unit can modulate, and whenever it sees that our superheat is getting low, instead of adjusting its inverter speed first, it may want to change the fan speed to bring more heat into the circuit. And so it can actually think about it. I mean, all we're doing is we're modulating superheat and subcooling. So now if we simply want to change the fan speed of a non-variable speed and it's a multi-speed, we can just simply change the speeds of the indoor unit because our capacity is increasing. The discharge temperature of the outdoor unit is increasing. Oh, I better do some modulating. Let me move the fan of the indoor unit and see if we can change that. And so we can actually convert that DC signal into a command signal and use this 24-volt interface module to use a communicating inverter ductless outdoor unit connected to a 24-volt legacy indoor system. That's kind of crazy, isn't it?
It is.
It's all about understanding how they talk.
Absolutely. Communication is key.
Wow. If I only knew how to do that, I might be a successful person. It's really about just understanding the things that we work with. It's about looking at things from outside of the box, understanding that the things that we work on, they may seem complicated, but if we can step back and look at it from a realistic perspective, we'll find that it's really not that bad. So, yeah. All right.
You know, when you go to a magic show, you see a lot of people just like impressed with the show, and then you always have a group of people that think, how did that happen? How did they make that actually work? And so Clifton, you and I are the people that's always like, how does it work? Let's see the science that makes that magic possible. And that's what this comes down to. Hey, we have these signals over here. Where's the extra wires? Where's the communication going? And it just comes to being that curiosity and finding out where it is. And I think it's awesome to be able to figure these things out, see the hidden magic, see what's behind the drapes, and get to see that in person, in hand. And then with the oscilloscope, it lets you see it. Like you can see exactly what's happening with it.
So we could talk about the magic smoke without letting it out.
Yes.
There we go. All right. So I think we're going to hop back over here real quick. I'm going to bring that third screen up. Hopefully they don't get too much sound. I'm actually going to go over here so you can see it a little bit clearer. I'll bring this one over here. That's right, Mr. Silberstein, enjoying the magic. I know, it's hard not to try to figure it out. I'm one of those guys. I'm like Ty, I watch the magic show and okay, what's actually going on there?
I'm
So
still trying to figure out how a bowling ball gets in and out of a briefcase, but one day.
One day. All right, so we're back to reading between number 2 and number 3. We can see our positive references to ground and our negative references to ground. We can see that they have varying stages, varying degrees between the ones and the zeros, both positive and negative. Let me get over here so we can see that a little bit better. All right, and I'm going to change the range real quick and see if we can get that a little taller for us. There we go. So as you can see, we're actually following a simulated sine wave. You can see it modulating up and down, and that is our DC voltage that is pushing our AC sine wave. So we have a variety of things being communicated all along that common path of number 2 and number 3. Any questions out there? Anything you'd like for us to go back and cover again or show some of these voltages again? Because it's very intriguing. Because once we understand that, it's as simple as checking the voltages at the outdoor unit, checking the voltages at the indoor unit. If they're not the same, we have a problem between the outdoor unit and the indoor unit. It's really about it. One of the most common ones that I have found out in the field, Ty, is that someone takes the ground and ties it into a lighting circuit ground where it's going to get mixed signals, where it's going to get interference from other wires. So when we're connecting that 4-wire cable from the outdoor unit to the indoor unit, never connect those to any other electrical circuit.
And nobody likes mixed signals. You know, right?
Oh,
Nobody likes mixed
nobody likes
signals.
mixed
We like
signals.
to know. What are you trying to say? I'll do it. Just tell me what you want. It
Tell me
makes
what you
life so
really, really
much
want.
easier.
That's exactly right.
But it also goes back to why those connections are so important. Since we're sending that AC and that DC signal, if we have a bad connection, where it's AC, it may just, push through, but that DC signal is going to get lost in those bad connections. The pulse is going to be different. It's going to be doing different things, or to just say, hey, I don't know what you're trying to say, and it goes in a lockout. So every single VRF manufacturer we've gone to has stressed the importance of having those connections right. They say, no wire nuts, making sure that it's a certain type of crimp, a certain type of wire, so that that communication can get from point A to point B without being interrupted in the middle.
Yeah, absolutely. We can look at any of these wiring diagrams and it will tell you without telling you the importance of a dedicated ground circuit. Like if we look at this particular one, our incoming power, right, is coming in over here at power supply. So this particular one would be our 240 volt system with L1 and L2, and its ground is passing through. It is connecting on the ground terminal and going directly back into that indoor board. And if we look at our communication, number 1, number 2, number 3, and then it's dedicated ground going to the indoor unit, it is also grounding onto that same terminal. And number 3 is going to be that communicating signal. So if we have any interruptions in our ground signal, it will be able to have an interference with our communication circuit. Oh boy, I am so glad that you brought this up. I know Ty had to jump off for a minute. So Robert, would you believe, let me pull this up again because this is pretty cool to see. I want to show you the one that I have. If Ty hops back out here, he'll be able to show you the one that he picked up. This is actually what I call my little pocket oscilloscope, right? So this literally fits in the front pocket. And this was, I think this one was $65 on Amazon with the probes and a variety of different terminals. And so I encourage you to utilize an oscilloscope, even if it's just out of curiosity to see what your signals are. So Ty, let's talk about the one that you have.
Yeah, I don't remember how much I paid for mine. Roman, he works over at in Florida,
Yep.
AC's, oh my gosh, you know who I'm talking about, AC, HVAC school. And he does a lot with oscilloscopes with the ductless and the communication systems. He used to work for one of the major manufacturers, and he had some really great discussions. And so eventually he was talking to me and he's like, hey, get one of these so you can see what's going on. Even if you can't do anything with that signal, it helps you see electricity, what's happening. And I always teach, we're teaching the invisible. And so he was actually teaching me how to make the invisible visible. And then from that, there's other adapters we can use too. I've now gotten an amp clamp that goes with this, and I'm doing some videos and tests for inrush current, because we hear people all the time adding start kits and they think that the start kit reduces the amps, and it doesn't. It just reduces it so fast that your meter can't read it. So I've now gotten an amp clamp with my, so I can attach it to my oscilloscope, and so I can actually record and show that the amperage is the same. It just adds, actually, it adds more amperage to the start winding. So really it increases the amperage, but for a shorter period of time. So that way I can, we can see what's really happening. Because this meter, which I love this meter, it can lie to us, right? It can not pick it up quick enough because it has a sample rate. And so there's things the oscilloscope does with attachments. And it, to me, it's cool being able to see what's happening. It's like a sight glass. We don't necessarily charge by sight glasses anymore, but it's really cool seeing the refrigerant flow through there. It's been cool to see the condition of the refrigerant. So in the ductless unit I actually installed sight glasses on both lines so that I can show people the state of refrigerant, because we always call it a liquid line, but in a ductless unit, it's not. It's a
No.
low pressure saturated line, where it's liquid and vapor. So we can see that. And then we can see the superheat coming back where it's actually just vapor. So it's pretty cool being able to see these things. And for me, it's just a really great way of being able to see some of those invisible things, or what was once invisible.
Yeah, exactly. When we think about this, Robert, this is such an important topic. I'm glad you actually asked about that. I have a variety of meters. I like to collect meters. I can't see all of them, but I've got a variety of meters around. And that is the least expensive meter in my entire arsenal. And it's an actual oscilloscope. So not only can I measure voltages in AC and DC, I can measure them exact and see what they're doing. So when it gets into diagnosing communicating systems, as you can see from some of our service manuals, a lot of times it's very vague on how do you check it. Put it on AC and see if you have a voltage between here and there. Well, it doesn't tell me a whole lot. I mean, it's a good guide, but it's not telling me exactly. What if I could simply take my oscilloscope, go to the outdoor unit, take a look at it. By the way, I can record on here too, so it's got a record function. So I can record what I'm reading. I can go to the indoor unit, see if I'm getting the exact same signal. If I'm not getting the exact same signal, something is interfering with my signal. That could be a grounded wire. That could be a shaved wire that has got corrosion all over it that doesn't allow for the communication to run through proper. It could be a ground tied into an electrical ground circuit for lighting, which the reason I keep saying that is I've absolutely encountered that before. The one that I found was it was a building complex designed for student housing. Instead of running the 14-4 stranded or 12-4 stranded between the outdoor and the indoor unit that is required for ductless installations, they actually ran 14-4 solid MC cable. And as it was running through the building, it was the wrong wire to begin with, but as they were running it through the building, the electrician came through, seen MC cable, put it into a box and tied all the hots together and all the grounds together. And all of a sudden they had like 140 units that couldn't communicate to each other, simply because they used the wrong wire for the wrong installation, and they tied wires together that weren't supposed to be tied together, and it burned out all the DC boards in indoor and outdoor units as well. So it really is understanding how things operate, knowing why we're using dedicated wire between the indoor and the outdoor units, and if we have a concern about the way that things are communicating, buy you a good tool and simply measure it. Now that you know how they operate, it's that easy.
You said Bayou? Are you going to be going to Louisiana soon?
Heading south, buddy.
Bayou?
We have been heading a lot. Robert, I hope you do get one. And any other questions, concerns, comments? We still have quite a few people out here. We want to make sure that we're covering any questions that you have. We've got copies of those IR videos if you need any of those for the classrooms to be able to show students exactly what they're talking about. I'm sure someone will get a kick that we're actually using a night scope for a rifle to be able to measure pulses off from a remote control. And that's really all that we're doing is we're just measuring signals with a different tool. And so all handy and all available for use if you need them.
And if you guys out there in the audience have questions, you want to say, hey, how does something work? Or how do I explain something? I need to be able to explain this to a class, or you're just curious, like, why does this thing happen? Be sure to reach out to us. Send us an email. We may not be able to get to everything, but if you have a question about how something works, or you're curious about it, there's going to be somebody else that's curious too. And Clifton and I both, we love to break out the meters and try things and explore things and do weird stuff to see if we can figure out why something works. I love going to classes with Clifton because they'll say something in a class like, "Oh, you'll have a constant whatever voltage," and Clifton will be like, and immediately I just look over and I can just see the gears turning. He's already
Is it?
processing all this information, and he's like waiting to get home to start doing all these tests. And I'm a lot of the same ways. There's different things that I'm looking at, and I'm like, let's figure that out. So anytime you guys have those questions, myth busting things, like we are all for that.
Absolutely, we are. I mean, that's why we do what we do. So that's a good question. So Ty, you had mentioned you want to explain a little bit about the other video that you've seen, because I haven't seen that video yet.
So I can't even remember what social media that it was on, and it was just really, I thought it was fascinating because we all know that we can send a signal through speaker wire to the speakers, and this was just really cool because it was just converting it to that infrared light. You couldn't see anything between it, but as soon as the guy put his hand in front of the infrared, it had stopped. So as far as seeing that infrared signal, like that was really smart thinking outside the box, Clifton, with your scope there. But I know that there's infrared lenses you can put on cameras. The catch would be getting it a camera that you could be able to slow down so you could actually see what that infrared signal was. But I imagine if you could capture the infrared signal, you could even see, is the device even putting out a signal? So, are we having a faulty remote at all? So if you could see that you are getting a signal out, then that would be part of that diagnostics. Although these are so cheap now, you could just replace them.
Yeah, absolutely. So I did find one really interesting site that it was an IT site, and they were testing different remote controls, and they were using a IR receiver that had a USB connection built into it. So it was just a small circuit board and a cable back to a computer, and could use its own software to record infrared signals from different remotes, and then that way you actually had the data. And I didn't go that deep. I wanted to do something kind of fun, so I was able to do it with what I had.
Well, if we think about universal remote to do the same thing, they
Yeah.
just, they're using that programming for that infrared light going over to the TV to receive that signal. And of course, we all lose that remote, but they have the universal ones that just have multiple different signals built in so they can communicate together. It's all about the communication.
Yes, it is.
And
One thing. Oh, go ahead.
Clifton sent me one of those thermostats that he has, and we're actually going to mount that on our wall because we like to be able to have a programmable thermostat, change the temperatures, and we lose the remote all the time. So yeah, I'm going to actually be installing one of those in our house.
So I wanted to bring that up. So one final point. So Ty and I like to try new products, especially when it pushes the boundaries of problems that we have in the industry, and they create solutions. And so if we think about that, I'm the same way. The infrared remote controls are easy to lose. So a company called CIELO came out with this really cool product line. And I don't like to push products, but I will push this one, because here's what we do. We actually pair the infrared. So you use an app, and with the app, it took me just a minute or so to download it. And then with the actual unit, it can be wall mounted or it can be table mounted. So it's got a traditional back. So you have a back plate that can be mounted on the wall and using 24 volts AC from a transformer, or you can use the supplied 5-volt DC USB-C connection with a plug. So you can mount it on a wall or you can put it on a stand. So what you do is you download the app, and then you add the thermostat into your app, and then it commands you to take your remote control to point it at the thermostat, send a command like it just did, and then it actually recognizes, reads that command, knows what thermostat, because they've already deciphered all the different codes that are being used from infrared manufacturers, and went, oh, I know who you are and what model you are. And it copies all of the codes that would have been utilized on this, and then adds all of the additional functions of a traditional thermostat that's connected to a smart service. As well, they do their regular smart thermostats connected to a traditional 24-volt system. And so you can build your own network of 24-volt AC legacy thermostats, as well as our paired thermostats. That's right. You better get him, Perla. He's got it in his hand. He needs to get it connected now, doesn't he? Yeah, because it is a common thing to lose the remote controls. If I can now put this on a table or put this on a wall and actually be able to build schedules and run all of my ductless systems off from one app. And I don't remember how many it was, but it was hundreds that could be utilized through this network, through their application. So if I'm a multifamily, if I'm a hotel that's using wireless, I'm going to a new system, I can actually integrate these thermostats and have multiple control with different groups. So great setup.
And for us, we like to be able to have a little cooler at night when we sleep, a
Mm-hmm.
little bit warmer during the day. So by the time we're waking up, it's already the house is the temperatures. And these have timers,
Yeah.
but you can't actually set a schedule with it.
Program.
So that's
Yeah.
why we're super excited about this. And because AC/DC, we had to go back in black. But yeah, this will be mounted soon.
Oh, that's a great one. Very, very good. So yeah, have to check them out if you're interested in doing a connected IR control.
And
I like
again,
it. I haven't.
we're not sponsored. This is just
No.
cool stuff that we found, right? Like we don't get anything for that. It's just like, hey, this is some cool stuff that we're trying out ourselves. We get excited about. We're nerds. We get
Absolutely.
excited about new
Love
products
it.
and new tools and meters and all
Mhm.
kinds of stuff.
No one else does that. And so now we have a third-party company that does it. And they're like, I'm not even going to tell you how reasonably priced both these thermostats are. You're going to go out there and check for yourself. So CIELO, do some of your own discovery. All right. Anything else we want to touch on before we hop out of here, Ty? That was a great conversation.
Oh gosh, well, we could just go all day long about these things, about ductless units and cleaning them. And it's amazing, you and me both. We have these, and we hear people say all the time, "Oh, those aren't going to work," but I love it. There's one in the studio right now, and you can't even hear that it's running. It is so incredibly quiet and very comfortable in here. So it's really nice, and it's really been fun having that to explain stuff. But we're learning new stuff all the time. So as we learning stuff, we want to share it with you guys. So y'all have questions out there, be sure and ask, because Clifton and I, we'll talk all day long. We have to have timers set for our meetings because we get off topic talking about everything.
This is actually like one of our regular meetings, by the way, those of you who are joining us. All right, everyone, we're so grateful that you've joined us, and we're going to be out on the road exploring new technical training facilities. Next week, I'll be up in Chicago checking out the Mitsubishi laboratory. We're going to be doing some bulk recording of some blower door testing at a fire station, diving deep into system management, and especially with temperature and humidity controls. And so we have a lot of topics we'd like to cover. We're here for you. Like Ty said, if you have something you want covered, let us know, and it will be covered in the months to come. So thanks for joining us. Thanks for being here, Ty.
Thanks for having me.
And we'll see you all next week on Did You Know? The ESCO HVAC Show.
HVAC Show.